Hello and welcome to level 2 of Ohm's law. These questions are slightly more tricky, although not always. The only slight complication here is that the voltage cell you'll see is the other way round. So this point here at the bottom of the circuit is actually at a higher potential than this point here at the top of the circuit, which means that the current is actually flowing this way, in through the black terminal and out of the red terminal of the ammeter. But ammeters measure current flowing in through the red and out through the black. This particular current is flowing in through the black and out through the red, so the ammeter says that's a negative current, minus 2.545 microamps in this case. It just means it's flowing in the other direction. Anyway, what value does the voltage source have? Well, applying Ohm's law again, it's just delta V equals IR. The voltage across this resistor will be the voltage generated by this voltage source. So that is just going to be equal to the current, which is 2.545 microamps, multiplied by the resistance, which is 110k. Fine. Next. This time, what value does the resistor have? This time we have the voltage across the resistor, and again we have the current flowing, and the voltage at this point here is higher than the voltage at this point here, so the current will be flowing in this direction round the circuit this time. But you'll notice that that is flowing in through the black and out through the red terminal of the ammeter, so the ammeter registers that as minus 6.875 milliamps. But all we need to know to calculate the value of the resistor is the absolute magnitude of the current, and we have 6.875 milliamps flowing in this clockwise direction. So here, what value does the resistor have? Well, that's just 110 millivolts divided by 6.875 milliamps, about 16 ohms. Next. What value does this resistor have? Well, 1.9 volts, 25.33 microamps, and it's minus. When you're asked what value does the resistor have, you don't really have to think about the direction of the current or whether it's negative or not, because you know that the resistance must be positive. There's no such thing as a negative valued resistor. Well, there is such a thing as negative resistance, but you're not going to meet negative resistance or a negative resistor in this module at least. So we know this value here is going to be positive, so we just take the positive current, 25.33, and the positive voltage, 1.9 volts, and we do 1.9 divided by 25.33 microamps, and that gives us the answer. Note that due to rounding errors, the answer calculated is 75K01, which is not exactly the value of this resistor. That's because the ammeter here can only express the current to 4 significant figures. If we actually typed in 25.33333333, which is the actual value of the current here, then we would get the resistor spot on correct, but you cannot display that value of current on this ammeter. So don't worry if the answer here is slightly different from the given answer. That's just going to be due to this kind of rounding error. I'll just do one more. Value does the voltage source have here? And this time the current is flowing anti-clockwise. It's a negative current. It's flowing in through the black and out through the red. So it's flowing from the negative terminal here to the positive terminal of this voltage source, which is the normal direction that current flows through a voltage source. So what value does the voltage source have? Well, it will be the current, 6.538 microamps, times the resistance, 1 meg 3. Again, it's just Ohm's law. Delta V equals I, the current, times the resistance, R, and there is no potential drop across this ideal ammeter because it has zero resistance. So all of the voltage across the resistor, which we've just calculated here, that must be coming from the voltage source here. In other words, the potential difference across the voltage source must be equal to the potential difference across the resistor. So that will give us the right answer. Okay, I think that's about enough for level 2.